All right, so here's the question from class we were talking about with the differential equation. So in this question, this was from 2008. We're doing a skier. Remember, we had a skier going down a frictionless hill, and they're asking for us to derive some equations. The part A is to actually do the free body diagram. Part B is to write a differential equation that we can use to solve for the velocity as a function of time. C is an expression for the terminal velocity. And D is now to solve the differential equation from part B. That's kind of where we messed up a little bit in class. All right, part A is easy, the free body diagram. Remember, so you have the normal force, you have this drag force, and they give you essentially the formula, a negative BV. And remember, FG on inclined planes is the only one that does not follow the incline. Okay, so part A. All right, so that's the answer to part A. Remember, on your scoring free body diagram, don't break up the weight vector, right? Don't break it up into FGX, FGY. If you want to do that, do it off to the side, okay? Part B, the differential. So what we're going to do is we're going to sum the forces in the x direction because that's where the drag force is, okay? And so we're going to do FGX minus FD equals MA, okay? Because remember, that's going to be our acceleration. Let me zoom up, let me pan up a little bit. All right. Now, remember, this is where the velocity is contained. So that's going to be dv dt, right? So we get FGX minus FD. Okay. FGX is mg sine theta. FD is given to us as BV. And then we have mdv dt. Okay, the only thing that we can do here really to clean this up is to divide the m over, right? And so it'll be g sine theta minus bv over capital M times d, or equals to dv dt. So that is the differential eventually we can solve for part B. Okay. Part C is what is the terminal velocity. So we can start with this g sine theta minus dv over m equals dv dt. So remember, this is our acceleration, and at the terminal velocity, that is 0, okay? So what happens is g sine theta minus bv sub t divided by m equals 0, right? And so then we can multiply that m back through. So mg sine theta minus bvt equals 0, okay? And then subtract over the mg sine theta, and then divide by negative b. So you end up with mg sine theta divided by b is our terminal velocity. Okay. And now I've run out of room here on this page. So what I'm going to do is I'm going to go to where there's actually a graphing question here, but we're going to not do that. And so we're going to bring back in the g sine theta minus bv over m equals dv dt to find our v in terms of t. So we're going to mg sine theta minus bv equals m dv dt. Okay, so here's where I messed up in class a little bit. We can do some, right? So we need this mg sine theta minus bv on the right-hand side. We need everything else on the left-hand side. So I'm basically going to multiply both sides by dt over m. All right, it'll get rid of it over here, and it'll show up on the other side. just going to leave me my dv dt on my right-hand side, okay? And then I'm going to divide by this mg sine theta minus dv, so dt over m equals 1 over mg sine theta minus bv dv dt, or dv. In fact, I put a dv dt here when it should only be dv. Okay, so dv. Right? Now I have my differential, right? I separated the variables. I have t on one side and I have v on the other. So now I can take the integral. Okay, so that's like saying 1 over m, the integral of dt, equals the integral of 1 over mg sine theta minus dv dv. Okay. Now for this part, all right, so for this integral, I have to do u substitution. So I'm going to do that kind of, I'll do it in a different color off here to the left. So what I'm going to do is say u equals mg sine theta minus bv, okay, and then the process is now do the derivative. So dv du dv equals negative b, right, because mg sine theta for our problem is essentially a constant, right? And then, so this is really the only thing I'm going to take the derivative of, where the derivative of a constant is just simply v, or excuse me, derivative of a line is just simply the constant. Now, when I substitute, so at this point in time, I have 1 over m integral of dt equals the integral of 1 over u, right? So notice when I do that, I have this dv left over. So what I need to do is find dv in what I'm just doing over here in my u substitution. So that's easy. I'm going to multiply dv over negative b by both sides. So the dv's would cancel out here on the left. The negative b's would cancel out on the right. And what happens is I have a dv left, which is what I want. And then I would have negative 1 over b du. Okay, so now this is what I'm going to substitute in over here for dv. Okay, and then to make this look a little simple, I'm going to multiply the b over, or negative b. So it's going to be negative b over m. The integral of dt equals the integral of 1 over u du. Okay, so now I can do my integral. So this is going to be negative bt over m. The integral of 1 over u is natural log of u. Okay, I also have to have my plus c here. Okay, and now I'm just going to start solving this out for v, right? I'm going to do e raised to both sides. And now when I do e to the c, that's just simply, hold on, that should not be there, sorry. So e to the c is just going to simply be c, right? And so I'm going to have c e to the negative bt divided by m equals u. Okay, now u was that mg sine theta minus bv. So c e to the negative bt over m equals mg sine theta minus bv. Okay, and now we need to figure out what that c is. And so they tell us way back on the top of the problem that when it is at rest, right, at t equals 0. So what I'm going to do is say, okay, my v is 0, right? So at t equals 0, b is 0, or sorry, not b, but v. Right, so b is equal to 0, so I'm going to plug that in. So c e to the negative b times 0 over m equals mg sine theta minus b times 0. Okay, so all I did was plug in my zeros. And so what happens is this whole term here is 1. So it's going to be c equals mg sine theta. So that's going to be my C. Sorry, I'm kind of running out of room. I'm writing big, but I'm trying to. And so now my function at this point in time is going to be mg sine theta e to the negative bc over m equals mg sine theta minus bv. Okay, and now I'm just going to solve it for v. So I'm going to subtract mg sine theta. And in fact, I'm going to factor that out because you're going to see it's going to be the same. So mg sine theta equals, or e to the negative bt over m minus 1 equals negative bv. And I'm going to divide all this by negative b, and that's going to give me my final answer. So mg sine theta times 1 minus e to the negative bt over m divided by b. Okay? And so there is my velocity, right, at any given point in time as a function of t. So that's the, again, 2008 AP Physics C exam, question number 1 on the mechanics.